Welcome to our short video on the fundamental concepts of statistics, population versus samples, point estimates, and confidence intervals. Understanding these concepts is crucial for making sense of data and drawing meaningful conclusions. Let's dive in. By definition, in statistics, a population includes all the members of a special group, while a sample is a subset of the population. In statistics, a population refers to the entire group that we are interested in studying. It's the complete set of individuals, objects, or even events that we want to analyze. For example, if we are studying the height of all adult women in a country, the population would include every single adult woman in the country. Now, a sample, which is actually a subset of the population, it's a smaller group selected from the larger population. In our height example, instead of measuring the height of every adult woman in the country, we might select a smaller group, perhaps a few hundred women as our sample. Now, once we have defined our population versus our sample, we are interested in understanding certain characteristics of the population and sample, which we call them the parameter and the statistic. So before defining what is the parameter versus a statistic, let's talk about the number of subjects. The number of subjects of a population is shown with capital letter N, and the number of individuals or members or events of a sample is usually shown with letter N, small n. Now let's define the parameter versus a statistic. A parameter is actually a characteristic of a population. A parameter is a characteristic of a population. It's a fixed value, but often unknown because it's impractical or impossible to measure every member of the population. In our height example, the average height of all women in the country would be a parameter. On the other hand, a statistic, which is a characteristic of a sample, is a measurable value calculated from the data collected in a sample. Going back to our example, if we measure the height of the women in our sample and calculate the average height, that would be a statistic. Now, in summary, population encompasses the entire group we are interested in, while samples are smaller subsets drawn from these population. Parameters are characteristics of population, and a statistic are characteristics of sample. Now let's talk about the process of sampling or coming up with a sample from big population. Okay, so sampling is a critical concept in statistics and plays a central role in how we gather data and make inferences about population. Sampling is the process of selecting a subset of individuals or items from a larger population. This is the larger population. This is the subset of sample, or the subset or sample, and the process is called sampling. Okay, so the sampling is a process of selecting a subset of individuals or items from a larger population to represent the characteristics of that population. It allows us to study a smaller group in detail while drawing conclusions that can be applied to the larger population. There are various sampling methods, and each has got its own advantages and limitations. Random sampling, for example, involves selecting individuals from the population at random, ensuring that every member has an equal chance of being chosen. This helps reduce bias and ensure that the sample is representative of the population. Another method is stratified sampling, where the population is divided into subgroups or strata based on certain characteristics, and then samples are randomly selected from each one. In the In the future videos, I will be talking more about the sampling process. But generally, sampling is essential because studying the entire population is often impractical or impossible due to factors like time, cost, and logistics. By selecting this representative sample, we can still make a valid inference about the population as a whole. However, it's crucial to remember that the quality of our conclusion depends on the quality of our sampling process. Biased or non-random sampling can lead to inaccurate results and not good conclusion. For next time, when you come across a study or survey, consider how the sampling was concluded, because it's the foundation about which the reliable statistical conclusions are built. Okay, now calculating the mean of a population versus the mean of a sample. Let's see what are the differences and similarity between these two. First, let's break down the process by talking about the mean or average of the population. Here you can see the formula that it's used to calculate the population mean. This letter is the Greek letter and it's called mu. Okay, and the population mean is calculated by summing up all the values in the population and dividing by the total number of values. Remember, the total number of values of the population is shown with capital letter N. So here in this formula, we are using the capital letter N. Okay, but when we're talking about the sample, the number of individuals is shown with a small letter n, and here, instead of using the Greek letter mu, for sample, we use x bar. So whenever you see x bar, remember it refers to the average or mean of the sample, whereas the mu represents the mean of the population. Now, how to calculate the sample mean? It's the same. The sample mean is calculated similarly to the population mean, but using the data from the sample. Okay? So, let's go back to our example. Suppose we want to find the mean height of all adult women in a country. In order to calculate the average mean of the population, the average or mean of the population, we would collect the height data of every adult woman in the country and then calculate the mean or average using this formula here, okay? Using this formula. But if we cannot measure the height of every adult woman in the country, we might select a smaller group, which is called the sample. This one, the sample. And then this is a subset, okay? Then we would sum up these heights and divide by the number of women in the sample to find the sample mean, okay? That's why here we have a small letter n. But there are very important differences and consideration between these two, which I want to draw your attention. While calculating the population mean aims to represent the entire population, calculating the sample mean aims to estimate the population mean based on a smaller subset of data. Remember that we discussed in the class, having access to the whole population, it's very impractical due to many reasons. Therefore, we usually do sampling. That means we come up with smaller groups or samples from the population, which the samples, each one of them, are representative of the population. Then we calculate the mean or average of the sample and try to relate it to the population by two methods, point estimate and confidence interval, that I will discuss it later. Point number 2 it is important to note that the sample mean can vary from sample to sample, whereas the population mean remains constant. Point number 3, when working with sample data, statisticians often use the sample mean x bar to estimate the population mean, which is mu, okay, acknowledging that there might be some degree of sampling error involved. Okay, this is very important. As I just mentioned, we can come up with many different samples from the same population, right? As long as each sample is unbiased and random, it's representative of the population, it will pass the criteria and would be an acceptable sample for the population. Therefore, the mean or average of each of these samples could be different from one another, but is still very close. On the other hand, we would assume that the average of the sample is very close to the average of the population, but with some error. Okay? For the rest of the video, I want to discuss about confidence interval and point estimates and how we use these two concepts to relate the average and standard deviation calculated from the sample to the population. Okay? So, when we want to estimate a parameter, which is for the population, such as the mean or standard deviation, based on the information or calculation from the sample, we use what is called a point estimate. And it's a single value that serves as the best guess for the parameter based on the sample data. So what we do here, we collect our data, we calculate the mean and a standard deviation of the sample and use it as an estimate for the mean and standard deviation of the population. Okay? Now let's move on to calculating the standard deviation of the population versus the standard deviation of the sample. As you can see here, the standard deviation of the population is shown with this Greek letter, which is sigma, whereas the standard deviation of a sample is shown with letter S. And how these two are related, the standard deviation of a sample equals the standard deviation of the population divided by the square root of small n, which is the number of individuals in a sample. Okay? Back to our discussion where we can get from the sample to population, or how we can relate the mean and standard deviation calculated from the sample to population. We already discussed about point estimate, and we mentioned that it's a single value that serves as the best guess for the parameter of interest based on the sample data. But as we know, relying only on a single point estimate or a single value can be very risky, as it doesn't account for uncertainty. This is where confidence interval comes and plays an important role. The confidence interval, on the other hand, is the range of values that likely contain the true parameter value. It gives us a sense of how precise our estimate is and provides a measure of uncertainty. Now, to do a recap on this video, population include all members of a group, while samples are a subset of population. And the process of coming up with a sample from a population. It's called sampling, and the sampling process should be unbiased and random. As long as the sample is unbiased and random, then it can be representative of the population. By calculating the mean and standard deviation of the sample and using point estimates and confidence interval, we can inference some conclusion about the population mean and standard deviation. Here you can see the formula for calculating the mean of a population versus a sample, the standard deviation of a population versus the standard deviation of a sample. So here, just to remind you, if you want to calculate the standard deviation of a sample, you can use the formula for standard deviation covered in the first chapter. A recap and summary of what we said during this video in the table format: parameter versus statistic, the source. When we're talking about parameter, we are referring to the population, whereas where we're talking about a statistic, we are referring to a sample. The notation we use whenever we're talking about parameter, we use Greek letters, which are mu and sigma, whereas for statistic, which refers to the sample, we use x bar and s. Okay? Some textbooks use x for data and x bar for the mean or average. Is it a random variable when we are referring to the parameter? No, it's not. But when we are referring to statistic, yes, it is, because during the sampling process, we have to make sure that each sample is unbiased and random. Can we or do we even calculate the parameters? No, we don't, because it's very impractical due to the cost, time, or many other factors. But we always remember, do our study on the statistic. We calculate and we do our analysis on the sample, on the statistics, and then we do some inferences about the parameter. And there are two methods to relate the statistics to parameters. It's either point estimate or confidence interval. Thank you, and I see you in the next video.